What is science? It's a surprisingly hard question to answer. I always think about a mural in the Vatican, painted by Raphael in the 16th century. In this painting, we see the Greek philosopher Aristotle holding his hand down to the earth. And next to him stands his teacher Plato, who's pointing his hand up to the sky. Raphael used these subtle gestures to symbolize each philosopher's theory on the source of true knowledge. For Plato, true knowledge came from thinking about the ideal versions of everything we see around us. But for Aristotle, true knowledge came from carefully observing the world as it is, making him the first scientist. It wasn't until 2 millennia later, in 1833, that the historian William Whewell actually coined the term scientist. Before then, people who studied nature were called natural philosophers. And in the centuries between the lives of Aristotle and Whewell, more and more people began studying the natural world's intricacies through careful observation. But science has arguably made even larger leaps in the period since the 19th century. We now know the age and constitution of the universe, the mechanisms of heredity and infectious disease. We can split atoms, and we can build machines that write symphonies and beat the best of us at chess. In other words, science has become an enterprise that permeates all corners of humanity, for better and for worse. It's led to dramatic improvements in the lives of human beings, but it's also led to much misery and suffering. How has this progress been made? And is this even progress? Is it real or is it an illusion? Our goal will be to take a close look at how scientists today generate knowledge. And along these lines, we'll ask whether their methods are really as reliable and objective as they seem. We'll also discuss whether non-scientific values such as moral codes, religions, or politics should play any role in guiding the scientific enterprise. Science is a word used in the public and political spheres. In her 2016 Democratic National Convention address, then presidential candidate Hillary Clinton said, "I believe in science," which was followed by roaring applause. Then after the election of Donald Trump, hundreds of thousands of people took to the streets all over the world for the Marches for Science. These people all took a strong stance for science, but what does that really mean? Or what are they marching for? Is it a method, a body of facts, a set of values, a group of individuals? Well, from the birth of careful empirical observation with Aristotle, to the solitary studies of Isaac Newton, to the observation of distant galaxies using the world's largest telescopes, science has constantly evolved and become more complex. Unlike centuries past, today science is a collaborative endeavor taking place in nearly every country across the world, and all of this work costs money, lots of it. In 2017, my home institution, the University of Pennsylvania, alone spent nearly $1 billion on research projects. The majority of that money came from the federal government, who will spend over $175 billion on research and development in 2018. And industry also funds millions of dollars of research at Penn and billions of dollars in the United States overall. So what are the end products of all of this spending? Let's take a look at a couple of recent examples. In 2017, scientists observed the merging of 2 neutron stars for the first time. According to the journal Science, it was easily the most studied event in the history of astronomy, with 3,674 researchers from 953 institutions collaborating on a single paper summarizing the merger and its aftermath. The first image of the neutron star merger was taken by the SWOPE telescope at the Las Campanas Observatory in Chile that we see in this image. The observation provided evidence to support Albert Einstein's theory of general relativity, a theory that continues to be supported to this day by observations. It also elucidated the process by which heavy metals like mercury and lead are produced in the universe. Last year, scientists also discovered more fossils of our species, fossils that led them to believe Homo sapiens has been walking around on this planet for not just 100,000 years, but 300,000 years. In other primate news, researchers also discovered a new great ape species, an endangered orangutan living in Indonesia. This was their first discovery of a living great ape species in 90 years. In 2018, scientists began the first experiments with humans using a genetic technique called CRISPR-Cas9. Their aim was to modify human immune cells to kill cancer. In that same year, researchers also found that emissions of CFC11 were on the rise again. This had been banned all over the world in 1987 because it puts holes in the ozone layer, which leads to more ultraviolet radiation making it to the surface of the Earth. Researchers have also begun to investigate the many ways that bacteria living in our guts, what scientists call our microbiome, might affect our physical and mental health. Their preliminary studies have shown that there could be some connection between the microbiome and obesity and immune disorders. Researchers also suggest that the microbiome may increase the risk of developing neuropsychiatric illnesses like schizophrenia, obsessive-compulsive disorder, ADHD, and chronic fatigue. It's very new work, and many scientists remain very skeptical, but this is normal for such a new research program. Studying the collision of neutron stars, dating our fossil record, measuring air pollutants, using genetic techniques to cure cancer, linking gut bacteria to illnesses, discovering a new orangutan. What do we think all of these disparate activities have in common? How do they fall under the same heading, namely science? Every question I have so far posed is a philosophical question. These are the questions asked by philosophers of science. As we've already learned, science has its origins in philosophy, but today the philosophy of science is a discipline that asks what science is, how it works, and what role it should play in our society. So many of the decisions we make in life rely on scientific evidence, from the chemicals we decide are safe to the way we raise our children, so we better understand why we accept the evidence in the first place. We should ask, is scientific research really the best way to answer the hard questions that society faces? Is it the only way? The philosophical analysis of science can elucidate answers to these questions.